Hey, welcome to Advancing AI, where we talk all things AI and machine learning. Now, are you wondering how to get started with version control in Databricks? Or maybe you've hit a wall with collaboration struggles and messy code merges. Now, don't worry about it, because we've got you sorted. Version control is your best friend when it comes to keeping your code clean, tracking changes, and most importantly, avoiding those costly mistakes. In this beginner-friendly intro, we'll have Stuart from Databricks back in to talk all things version control and to show you how to get started and solve those typical problems that teams face. Let's make version control easy so you can focus on building those harder, more interesting stuff like building some awesome AI solutions without any headaches. Now, don't forget to click like and subscribe if you want to see more videos like this. But more importantly, see you in a second. Hey, Stuart, nice to see you again. Welcome back.
Hi, Gabby. Thanks for having me back.
No, I mean, thanks for coming back to talk to us about version controlling in Databricks. So tell me, Stuart, what really is version control? And more importantly, why is it so important for data scientists or machine learning engineers to use version control?
Sure. Okay. Yeah. So data science as a field, it hasn't always had an easy relationship with version control, right? So in the software development world, yeah, it's very normal for every project to start with setting up some kind of repository for source code and that being managed quite closely. In data science, I think because of the kind of more exploratory and iterative nature of that kind of work, a lot of people have skipped that step traditionally and gone straight to building and prototyping things just to see if things are feasible. But as soon as you get to any kind of level of complexity or something that you want to deploy and govern in a kind of production environment, you really need to be using version control. And it just makes being able to collaborate between teams of more than one much easier. So you're not all treading on each other's toes as you go along.
Yeah, I think as well as that, right, it's also makes developing machine learning projects a lot more efficient, just because we know what it's like. Exactly what you said, Stuart. It's very experimental. You change certain parameters, or hyperparameter. You do your hyperparameter tuning, and you get different results. And you can very quickly lose track in terms of what's given us the best results, or what's produced the best models, and how is that developed into something further. I've also heard horror stories from customers where they've done 6 months worth of work and with a click, just lost everything without using or leveraging version control.
Yeah, right. So it has a function as like a kind of a tool for backing up and being able to go back to a known good state. Yeah. But it's one of the three variables, especially in data science model training kind of workflows. It's one of the three big variables that you need to hold constant in order to have reproducible results, with the other two being data and like the hyperparameters that you put into whatever model training algorithm you're using. So yeah, it's kind of that's where it sits in that.
I mean, you've written up a great blog about version controlling in MLOps Gym series, but I was just wondering, can you give us an overview in terms of how would a beginner get started with version control on Databricks? I mean, is there a step-by-step process they can follow, or you can take us through, Stuart?
Yeah, I'll just take you through in a second. Yeah, the blog post was actually 2 blog posts, right? Because there was quite a lot to it to kind of get through. But the first one is really about, okay, how do you set your environment up so that you can easily link to like a remote version control platform. And the second one is, okay, as soon as you start doing this and you collaborate as a team, you're going to hit the situation where you need to be, you have like a divergent versions of the code, and you need to be able to reconcile between those. So like, show you a quick demo of basically how you can do that end to end. I don't think it'll take very long. And then by the end of that, hopefully everyone should have a bit of a better idea of how we can get that working in practice.
Sounds good.
All right. So yeah, you're my #1 partner. That's why.
I like what I'm seeing.
So we're gonna work in, this is an Azure Databricks workspace, but the advice here goes for whatever public cloud provider you're using Databricks on. And we're working in the same workspace where would normally work with notebooks and Python scripts and all that kind of stuff. So this is where I'm going to start.
Okay.
As well as the Databricks workspace, I have to have some kind of remote version control platform, right? So you've probably heard of these before, GitHub, GitLab. The one that we're going to use today is Azure DevOps, right? Because a lot of our customers who use Azure Databricks use Azure DevOps alongside it because the two integrate really nicely. So this is my user organization within Azure DevOps. And so in order for the two systems to talk to each other, I usually have to link accounts. So from inside the Databricks workspace, if I go to my user settings, there's an option down here around linking accounts. Now, actually, with Azure DevOps and Azure Databricks, there's no need to do that because they have the same identity provider, which is Azure Active Directory. Or what was called Azure Active Directory is now Entra. But yeah, let's go ahead. So this is my organization within Azure DevOps. I'm going to just create a new project here. And inside this new project, I'm going to create a blank repo, which is where I'm going to start working. So down here, repos, let's take there. Right, so advancing analytics is empty, add some code, right? So this is what I want. I want a completely empty repository. I just need the URL for this repository, and I can go ahead and create something called a Git folder inside the Databricks workspace. So in the create menu here, Git folder, and I just paste that URL into the box. It knows what the name of the repository is and suggests that's the name of the folder. It knows that it has to talk to Azure DevOps in order to do this. So I can go ahead and create that. And now what I should have is a new folder in the workspace with a few little Git things in here. So let's go in there. Now, if I go back to the repo in here and hit refresh, nothing's changed whatsoever yet, right? So I need to actually add something in here and make an initial commit and push it to the repository in order for anything to start appearing in my remote version control platform. So let's go ahead and do that. So somebody's asked me to create a notebook that does some kind of logging activity for the purposes of this demo. So let's go ahead and do this. This is the name of the notebook. And what I'm going to do is I'm just going to do it with a print statement, right? So with all the Databricks notebooks, you obviously have to attach it to a cluster in order to execute any code. So do that. Yeah, so now I can just execute this statement.
Okay, cool. If you didn't have a cluster that it's already switched on, Stuart, you can still commit your work, can't you?
You can, yes. So there's some interesting implications here, right? So by default, what happens when I commit, and we'll see this in a moment, I get the kind of the source code of the notebook boiled down into a single Python file, Python script, and then that's what gets mirrored into the remote version control system. Now I have some control over the way that works. So if I go into the file menu here, I can change the notebook format, right? So I can switch from what I've described, it turns it into Python source. I can choose to store things as IPython notebooks.
Okay.
And that's pretty neat for two reasons. So the first reason is a lot of version control platforms have built-in tools for rendering notebooks. So if people go and look at the code, they can see more than just the source code. They can actually see formatting, markdown. The other thing that's interesting is you can enable this function, is being able to store the output of notebooks with the notebooks themselves. Now be super careful with this one, right? Because if you've got stuff that's coming out of your notebook that maybe you don't want to be committed to a version control platform, just be aware that that's happening and don't enable this feature.
Okay. One other question before you move on. should. What's the difference between, so committing into Git and using the local version control?
Right. Yeah. So everyone, well, people will have seen this function, right? And in the past, this is all we had for version control within Databricks. Yes. So you had the ability to see diffs between versions of the notebook and to roll backwards to previous versions. And that's because, like, under the hood, the Databricks notebooks, they aren't really files at all. They are stored in a database which has, kind of a log of transactions and everything, so we can go backwards through them, retrieve old versions of people's code. So that's helpful, but it doesn't solve any of the other things around version control, like being able to collaborate with other people in your team and work on different parts of the code base and then bring those together. So it's purely for being able to undo something silly that you've done and broken your code, or rescue that demo immediately before you need to go and talk to the next customer that you managed to break through doing something or other.
And I guess, the other important point to note about the version history that's embedded within Databricks is if you were to delete your Databricks instance, it's all gone anyway. So it's always important to.
Sure. So obviously, like, you have the option to delete notebooks by moving them to trash. And it's a nice message that says, like, after 30 days, we'll probably delete this. Are you sure? Yeah. If you let that time elapse, then your notebook's gone forever. If somebody accidentally removes your workspace from your cloud provider's environment or whatever, it's gone. But if you were using version control, then you have some record, or it might not be exactly where you got to. It'll be just where you made and pushed the last commit. So I'm going to go ahead and make this first commit now and I can do this. I mean, for the first commit, you can do this straight onto the master or main branch of your repository. From that point onwards, we'll talk about feature branches in a minute. Let's just give the ubiquitous first commit. And so what this is going to do is going to take the stuff that I've added to this Git folder, and it's going to turn that into a record of changes called a commit, and it's going to push that commit into the remote version control platform. And so now if I refresh this page, you can see I now have something that looks like the workspace folder structure that I was just working in. And you can see it has, like, who did this, what the commit message was, etc., etc. And over here, I've got a single line in the history which says Stuart made a first commit.
Cool.
Right. So pretty simple so far.
Now
I'm going to talk about the situation where you're collaborating with other people and you want to work on separate parts of the code base and reconcile your changes and all of those nice things. So I'm going to set it up quickly just by creating a branch which we'll come back to later. So something I should probably talk about here is naming things. So everybody knows in computer science, naming things is hard. And so people often get a bit, almost like religious about the way that they name branches, feature branches. So in the blog, there's a link to a kind of a guide of how you can establish a convention for naming your branches, and it's just really nicely written, and it's super simple. It basically says, like, name it with some prefix which describes what it is that you're doing. Like, are you fixing something? Are you extending the capability of your code base, whatever?
Cool.
So let's say, okay, right. We'll come back to this in a minute, right? So, but I'm just going to create it now so that it's linked to the current state of the main branch, because that will explain how we can merge changes and resolve conflicts. So, but for now, we're going to work on a new branch. So one of my colleagues has looked at my code, which has been used for a while, and has said, well, hey, if the name of the notebook or the thing that I put into the notebook has some kind of sensitive information in it, you just print it out directly, and that's a problem. Because of our security policy. So I'm going to make a more sophisticated logging mechanism, which hopefully catches some of those things. So let's go ahead and create a new branch here. I'll call it PII, right? Even though notebook isn't PII, but you'll see where we're going with this, right? So here's the new branch that I'm working on. So you can see nothing's changed. It's just a mirror of the master branch. So what I'm going to do is I'm going to create a new file in here, which contains my logging utility.
Okay.
Okay, so let me just do with the magic of cut and paste. Okay, so here's my logger, right? If you want this explained. So when you initialize it, you pass in a name. When you call echo, it returns what its name is, but a kind of a sanitized version of it. And so now I can update my notebook code to work slightly differently. So if I do, so the first thing to say is, like, you can import classes from kind of sidecar files here. The Databricks notebook. So I just do like from utils import special logger, right? But every time you do this, you need to detach and reattach the notebook to pick up any changes or any new files. There is a way around this. It's in the documents.
Okay, cool.
But I'm not going to show you here, right? So the first part is I need to import that class and then create a new version of this, a new instance of this. Yeah, so with the name in it, and then I just call logger.echo. And there you go, it's kind of redacted my sensitive information. So that's exactly all the changes that I needed to make. Now I want to take this stuff that's on my branch, commit it to the remote version control platform, and go ahead and then merge that into the master branch of the code base. So again, I'm going to make another commit. So here we go. Some sort of informative message for what I've done. And then just check these are the things that I want to commit, and this is the code I expect to be in there. It's all good. So let's commit that and push it up into Azure DevOps. Great. Okay, that's all worked. So now you can see it gives me a message which says, "Oh, hey, you push this to this branch. Go ahead and create a pull request on your provider." So inside Databricks, we don't like hijack any of the processes of the remote version control systems. We leave that for those tools because it's really nice. Those tools, there's no need for us to kind of duplicate that functionality. So inside my Azure DevOps project, if I just refresh this again, I'll see, oh, you've just made an update on this branch. Do you want to go and create pull requests? Well, sure, yeah. I want my colleague to just have a look at this and check it's all okay. If they're good with that, then we can merge it into the master branch. And so I would probably like put something more instructive in the description here. So like, whatever, right? Bunch of like who updated the documentation, that kind of stuff, all the good stuff you should be doing. And then I would pick, maybe I'd pick Seppi as my reviewer here. I won't, because this is a project I've created without any of the usual controls. So I'm going to make myself the reviewer for this to show you just how the review process works. So I can go ahead and create this pull request, and you see that it's saying Stuart's proposing to merge this branch into the master branch, and there's no merge conflicts. Everything can be merged easily because no files have changed in the background while we've been working. And so as a reviewer, what I can do is I can see a diff of all the files, which is this kind of same thing we were looking from inside the workspace. So I can have a look at the code, what's changed, what's been taken out. And I've got a history of all the commits that have been made on this branch. So usually with feature branches, have more than one commit. Well, you should do, right? You should.
Yeah, you should. Yeah.
Like, as you go, not leaving it for like a one enormous commit for somebody to figure out what on earth's going on. But yeah, this looks good to me. So I'll go ahead and approve this. So I've got a little tick in the box. And yeah, we can go ahead and merge this into master now. So let's go and do that. Now, there's some options here around how I merge my feature branch into the main or master branch. And this is really, all this determines is what the commit history looks like once this merge has happened. So the options, the kind of most common options are, I'll merge it so that I will take the history of this branch and put it on top of this branch, and so I'll be able to see all of the history of these commits. So that's kind of the most common way of doing things. I might choose to, like if I had multiple commits in my branch, I might choose to squash all of those into a single commit and then put that onto the other branch. So that's kind of the second option. And then the third one, which is used a bit, is like rebase and fast forward. So basically, I'm going to take the starting point for my branch to be like the current position of the main branch, and play all of my changes on. And like this would solve the situation that I'm going to show you in a second, but we won't use it because so things are usually more complex than this, and you usually have to go to like some kind of manual resolution of conflict. So we'll go with this merge, no fast forward sort of approach. So that's done, and I can close this. And it gives me the option to kind of like delete this branch. That's usually what you would do at that point. And now if I go and look at the master branch, you can see, yes, okay, I've got this extra sidecar utilities file that's being added, and yeah, here's the latest commit against each of those files. And then in the history, you can see what happened here. So over here, I branched, I made a commit on this branch, and then I merged the two together here, right? So that's exactly what I expected to happen. All good so far. Now, in the background, my colleague decided that our original version of the logging tool wasn't quite like exciting enough for him or her. So they're going to go ahead and jazz this up a bit, right? So they're going to take my original print statement, and they're just going to kind of like go to town on this, right? So they've decided that every time we print something, depending on exactly what time it is, we're going to print an emoji with the name of the notebook, right? So we're going to choose an emoji based on taking the system clock and performing a modulo operation on that, and use that to pick a particular emoji, and then they're going to insert this into whatever gets logged out the notebook. So yeah, here we go. Right, picks an emoji, prints it with the output, and yeah, so they're going to go ahead. They've completed this work. They want to then commit and push this into the remote. So okay, here we go. Okay, cool. Right. So we go ahead and commit that. Now they get exactly the same message here, which says, yeah, we successfully committed and pushed your changes onto this branch. Go ahead and open a pull request in your Git provider. And so over here, they go back to the Azure DevOps repo here, and you see, oh, okay, right, this branch has been updated. Let's go and create a pull request. Again, they make this a bit more explanatory stuff. Add a review maybe.
Yep.
Create a new pull request, and you see this time they've got a message that says there's a merge conflict here, right? Because while they've been making this change, we've gone ahead and merged a bunch of changes into this I am a notebook. And yeah, so the current state on master of this file is different to the state when they started making their changes.
Yeah.
So they'll usually be blocked from merging their branch in without resolving this merge conflict.
Right. Yep.
And the nice thing is that actually Databricks has some tools for helping with resolving these conflicts. So let's take a look at what those look like. So if I go back in here and I look in the Git dialog here. So I'm still working on the same branch. Over here, I've got in the kebab menu here, I've got some other options here, right? So basically, I can merge in all the changes from another branch in my remote onto this branch, and then use that to resolve conflicts. So I'm going to use the merge one here, and I'm going to merge from master so that I can basically take all the changes that have happened to master, play them onto my current branch, and then create one final version which has both sets of changes in. So yeah, let's go begin merge. So you can see I get this kind of resolve conflicts dialog here.
Yep.
And it explains what's happened. So I need to resolve these conflicts. The easiest way is in the little editor down here. So you can see in this first section, this is the stuff I'm trying to commit into the remote. Right. And here are the things that are already in the remote that aren't in my version. And this is in the file that has a conflict. You can see there's also a file that's been added. And so that will be reflected in my branch now as well. So I'm just going to go and tidy this up and work out okay, well, I can get rid of this kind of stuff that has been added from the, but I want to take, I still want to take my exciting
emoji generator.
Exactly, yeah. So create the logger, and then I'm going to just use this inside the logger logic, and then I don't need this bit because it automatically prints out IAMA every time anyway. And so yeah, here's our kind of final conflict resolved version of this code. So I go ahead and mark it as resolved, and then I can go ahead and continue the merge, and that should bring all of the code together into a new consolidated version in the branch that I'm working on in here. Or it should do. Now, why did it? Oh, hang on. I just need to refresh this. And that gives me a version of the code that has all of the components from the branch and the changes that I've made. So all good. I can test it by running it in here, and then I can go ahead and make a final commit. Oh, well, it's done that in the background. So it's done the final commit for me as part of the resolution process.
Okay, cool.
So back to my pull requests here, I can see that there are now no conflicts. Some new changes were pushed. And then again, it's the same process. So someone can go ahead and look at the diff here and work out what's changed, what's been updated. And assuming they're happy with that, they can approve it and then complete using the same process that we showed before. And so that that's a sort of trivial example of performing this kind of conflict resolution. But yeah, every kind of scenario that you hit with working together as a team will be some variant of what we've just looked at there.
Yeah, absolutely. Yeah.
So hopefully that gives you an idea of the basics of how to get these things all working together.
No, that's very useful. I mean, I think what you've just shown there is very common. Most data teams, most machine learning teams would absolutely hit those issues that you've demonstrated there, Stuart. But what's one mistake you often see teams make when using version controls, and how can they avoid it?
Yeah, okay. I suppose the biggest thing is, and this relates more to when you start to layer automation on top of these repositories, right? Because all of the version control platforms that are out there allow you to add hooks into these little processes, raising pull requests and stuff, so that tests can run in the background and everything. The problem happens when these repositories creep to cover like lots and lots of parts of, or lots and lots of different projects, or lots of different parts of a particular project. And so, if you've got your data pre-processing pipeline and your model training and evaluation code and your like production inference job and all of that kind of stuff, consider separating those out into their own repositories versus having them all living together, because it just makes the process of setting up the automation a bit easier. So it will vary from situation to situation, right? And you can reason about it as a team. Whether, actually it's really important that I can be able to test the whole thing end to end. Well, okay, you might want to have everything in the same place. Or if I want to be able to iterate on separate parts very quickly, maybe it's better to have them separated out. I guess that's like the main thing that people hit.
Cool. Well, that was very helpful. Thanks for coming along, Stuart. Thanks for showing us how to get started using version control, typical issues that people tend to hit when using version control. So thank you very much for your time, and hopefully catch you soon, Stuart.
Thanks, Gabby. I'll see you around.
See you around.